Hi, in this video, I will be showing problem number 73 of chapter 11 section 1. Determine whether the sequence is increasing or decreasing or not monotonic. Is a sequence bounded? A sub n or the nth term equal to 1 over 6n plus 3. Let's consider the definition of when the sequence is decreasing, when the sequence is increasing, and when the sequence is bounded. If an plus 1 is less than or equal to an, or the n plus first term is less than or equal to nth term, for all n more than or equal to 1, then the sequence decreases. If a sub n plus 1 is more than or equal to a sub n, or the n plus first term is more than or equal to the nth term for every n more than or equal to 1, then the sequence is increasing. If a sequence is bounded above and bounded below, then the sequence is a bounded sequence. In other words, if an, the nth term, lies between two numbers m and lowercase m and uppercase m, then the sequence an is a bounded sequence. So let's consider a sub n plus 1. We are given a sub n. So if we change the n to n plus 1, we get an plus 1. Then we will compare what is the relation between a sub n plus 1 and an. If we are able to establish less than or equal to between them, then we can conclude that the sequence is decreasing. Otherwise, it will be increasing. So let's consider a sub n plus 1, which is 1 over 6 times. Wherever n is, that gets replaced by n plus 1. That is n plus 1 plus 3. That is 1 over 6n plus 6 plus 3. If you distribute the 6, it's 1 over 6n plus 9. So we have a sub n is going to be 1 over, it's given as 1 over 6n plus 3. So obviously, the denominator of a sub n plus 1, 6n plus 9, is more than the denominator of a sub n, which is 6n plus 3. So if you take the reciprocal on both sides, 1 over 6n plus 9 is less than 1 over 6n plus 3. This establishes an plus 1 is less than or equal to an for every n more than or equal to 1. Now this shows that the sequence an is decreasing. Is decreasing. That is the first part of the problem. We should also find out whether the sequence is bounded or not. So let's consider the first term, a sub 1. So a sub 1 is obtained by plugging in n equal to 1 into a sub n. So it is 1 over 6 times n gets replaced by 1 plus 3, so which is 1 over 9. Also we notice limit as n approaching infinity of an is limit as n approaching infinity of 1 over 6n plus 3, which is equal to 1 over a very large number, which is equal to 0. And then if you also consider a2, which is 1 over 6 times 2 plus 3, or 1 over 12 plus 3, which is 15. So we notice 1 over 15 is smaller than 1 over 9, or a2 is smaller than a1. So we can prove this for an plus 1 less than an, which we already did. The sequence is decreasing and then it lies between 0 and 1 over 9. So we can consider 0 less than or equal to an less than or equal to 1 over 9. So if you are able to find out two numbers, lowercase m, which is equal to 0, uppercase m, which is equal to 1 over 9 in this definition, then the sequence is bounded sequence. This shows that sequence an is a bounded sequence. Sequence an is a bounded sequence, or we can say sequence an is bounded. Hope this video helps.